of 3D printing news Unpeeled, courtesy of 3dprint.com. So today we're going to be discussing the relevant 3D printing news for today, and we start off with Osaka University. So Osaka University has developed a way to 3D print QR codes in cookies. And first it sounds kind of like a funny thing, maybe, or like kind of like a facetious thing, but this could actually be quite useful. So what they've done is they've essentially used the negative space inside of a cookie and the light you can shine through it to create shadows, which will then make a machine readable QR code. Their process or the technology is called Interi QR, which can put the QR code on the inside of, for example, a cookie. The work by Yamato Miyatake and his colleagues is meant to be a solution for maybe traceability, less food waste. Because so imagine, like, for example, putting this on the inside of a fruit or a vegetable, or putting this on an edible or a food label made from agricultural waste, or some kind of like a corn husk or something like that. Imagine putting the label on the corn husk, so you don't need to put a pricing tag or price label or anything on that, and make it more traceable, so when the fruit goes bad. This is the kind of thing that really could really make for an interesting invention, and save a lot of carbon, save a lot of material here and there. So it seems a bit funny in the beginning, but if you think about it, making kind of like edible QR codes, or making QR codes that help traceability using food materials could actually be quite applicable to a lot of different things. Another Japanese piece of news is from that Obayashi Corporation, which is one of Japan's top construction companies, is using concrete 3D printing and a Yaskawa robot. Yaskawa is another Japanese company, one of the largest industrial robot manufacturers in the world, to 3D print curved surfaces and curved building type of structures. What's more, they're reinforcing the walls with fiber reinforced concrete. And what they hope is that testing will show that they are able to then get buildings that are strong enough to comply with the building standard law. That's the Japanese law and building code, essentially, that is meant to do certain things like earthquake resistance. This, of course, is a much more stringent, much more important type of code than a lot of other countries, because Japan is an earthquake zone and has had so many issues with earthquakes in the past. The idea is that they can print these curved, quite complex structures without using additional steel frame or rebar, and that this could be a very efficient process. It hopes that the company Obayashi hopes that it'll be more CO2 efficient. It hopes that it'll be more efficient in materials use, and be more cost efficient as well. What they're doing is 3D printing at a location at the moment, or at a pre-prepared, covered up location at the moment. And the structure is just a 30 square meter curved wall structure. So, but they hope to incorporate like lighting and plumbing and all the other normal requirements into it. And Japan has been quite the sleeping giant. I mean, I think given its industrial might, given the number of manufacturing companies, given the number of large machine tool companies like DMG and stuff, its involvement has been very, very, very light in 3D printing compared to other countries like Germany. Apart from the fact, of course, that Sony made one of the world's first stereolithography machines back in the day. But Japan kind of dropped out of the 3D printing race for a lot of, until only, kind of this year, we see a resurgence of JOL coming in E-beam, Nikon making big moves in 3D printing. So we're seeing a lot of stuff where Japan's really becoming a player, and perhaps also in construction. Now, there's a real big reason why 3D printing construction in Japan should be a big deal, and that is that Japan has a smaller working population than it would like, and that is shrinking, and that working population is aging all the time, because of the dependency ratio of the country is also very, very high, and particularly in construction, the construction workers are aging out and are not really being replaced by a lot of new young construction workers. So perhaps putting robots in there will save labor, make the profession more attractive, bring in tech savvy people to, not lift bricks, but to man the machines. And that could really be a very, very big deal in Japan, much more so than a lot of other economies. Meanwhile, across the straits, across the ocean rival, China is not sitting still. Avi Metal AM, which is a subsidiary of Jincheng Electromechanical. It's a Beijing-based company that makes everything from gas bottles to everything's not a gas bottle, has now added a fourth in its lineup of LPBF systems. The M280, 330, 450, and 650. These are all open printers, so you have access to the settings and stuff. And it means that Alvi Metal has one of a number of Chinese companies that have a full lineup: E Plus, Farsoon, BLT, H3D, among them, really having a lot of different printers on the market. They're all very, very similar. It's very difficult to find differentiating features at the moment, but we know that the Japanese domestic market is hyper competitive, and this could rely on some new innovations and some new printer manufacturing companies as we go forward. The next thing is from NASA. NASA is doing a SBIR, STTR kind of technology transfer award kind of thing, meant to let small to medium businesses play in the space game. And traditionally, a big proportion of these awards have gone to 3D printing firms. And two of them that we'd like to highlight of the recent batch is it's interesting. I just read up on this, and I had missed both of these, so I thought it was interesting to review them to see where NASA's going. So one of them is Gigabot. So Gigabot is making a recycling system that's meant to take packaging and turn it into useful objects on board spacecraft. And Gigabot has flake and granulate 3D printers already, so it's going to be using the money to make a system that can take the packaging. And what's interesting, of course, is that NASA determines everything that goes up in its spacecraft. And so we know the melt pool, or we know the MFI of these plastics. We can stipulate what kind of characteristics these plastics have, and we can know their mechanical characteristics beforehand. So that's really nice about that kind of level of control. Also, packaging is something that they're going to require a lot of, and it's completely useless later. What do? Get rid of it, and then all of a sudden they have a need for some objects. What do they do? And then that's where 3D printing comes in. And the other reason, and I had not heard of this at all, is something by Canopy Aerospace. Now, Canopy Aerospace is going to use binder jet to print the TPS, or thermal protection system. These are more, it's also called a alumina enhanced thermal barrier, or shuttle tile, which you may have heard of. And these are tiles, essentially tiles, that are used on the outside of spacecraft to enable reentry. Famously, or more importantly at the moment as well, is not only they're used now for shuttle type aircraft and a lot of other reentry like aircraft, which are meant to, of course, make space travel more reusable, more applicable to more quotidian, more low cost things, rely on these aircraft, including the space vehicles themselves, to re-enter the Earth's atmosphere. Now, what the problem is that upon re-entry, they need these tiles to protect the craft, and these tiles are very difficult to make. In the SBIR grant thing, they say that it takes around one technician 2 weeks to make 2 tiles a week, right? And these tiles have to cover pretty much the body of the spacecraft. So there's a real bottleneck around these tiles, and what they're going to do is they use binder jet to make them. It's something they call the Reusable Heat Shields Additive Manufacturing Platform, RHAM. And the idea is that this will be able to make these tiles much, much faster than the traditional processes, and can make them tailor them. So there could be a tile presented at a different angle, for example, could have some different characteristics, or have a different internal structure. This is very, very exciting. And it could lead to these things being available. At the same time, the United States is also working on hypersonics, and they would really love this kind of heat-resistant technology as well. And the idea that they're using binder jet for this is, well, I think that's very noble. Not sure if it's going to work. Would be really, really very, very good if it did. So that's the news for today, and thank you very much for listening.